All right, welcome. Today we're going to demystify one of the most powerful tools out there for anyone doing web automation, XPath. If you've ever tried to get a script to click a button on a website, you know how incredibly important it is to find the right button every single time. So let's get right into it and solve the one error that breaks pretty much every automation script out there.
So let's dive right in. It all kicks off with this fundamental challenge that, if you're an automation engineer, you know this pain all too well.
Just picture this for a second. You write a script to log into a website. It works perfectly today, awesome. But what happens tomorrow when a developer pushes an update and the whole layout changes? How does your script find that exact same button? How can it possibly be reliable when the ground is constantly shifting underneath it?
Because if it can't, you get this. The dreaded element not found error. It's the absolute bane of web automation, and it's the exact reason we're here today. We're going to solve this.
Okay, so what's the fix? Well, the solution is this incredible language that basically acts like a GPS for every single element on a web page. And that language, of course, is called XPath. So what is it really? Well, XPath is a language built to navigate the hidden structure of a web page, what we call the Document Object Model, or the DOM. You could think of the DOM as the architectural blueprint of the entire page. Every button, every link, every image, it all has a specific spot on that blueprint. It has an address. And XPath is simply the language we use to write out that address. Okay, but here's the catch. XPath gives you two very different ways to write that address, and understanding the difference and knowing which one to use is absolutely the key to building automation that doesn't break a week later.
And it really is just like giving directions. You could give someone the super long turn-by-turn directions starting from the other side of town, or you could just point to a huge, unique landmark right next to your destination and say, it's right there. One method is incredibly specific but falls apart if a single road is closed. The other is flexible, smart, and way more reliable.
And wow, you can really see the difference right here. Look at the left, the absolute path. It's a mouthful, right? It's saying start at the HTML tag, go into the body, then the first div, then the header. It's this long step-by-step route. Now look at the right. The relative path is so much cleaner. It just says, hey, look, anywhere on this page for an input that has a name attribute of search. Boom, done.
You know, the syntax itself tells you everything you need to know. That absolute path, it starts with a single slash. That means start from the very, very top of the page. No exceptions. But the relative path uses a double slash, which is like saying, hey, search anywhere on this page for what I'm looking for. One rigidly follows the hierarchy, the other just finds a unique landmark and jumps right to it.
So you might be thinking, wait a minute, why wouldn't I want the most complete path? That sounds super reliable. And yeah, you'd think so. But that precision, it's actually a huge trap.
I mean, look, in a perfect world where nothing ever changes, this absolute path is beautiful, it works flawlessly, it follows the chain of command, step by step, right from the top of the page down to our target. The path is clear, it's unbroken, perfect.
But when was the last time you saw a website stay the same forever? Right, never. A developer comes along and adds a simple little banner ad, just one new div near the top, and suddenly, bam! The entire path you wrote is broken. Your script is now completely lost because one step in its long list of directions is changed.
And that is why we call absolute XPath brittle. It shatters with the smallest change. It's just not built for the real world, where user interfaces are constantly being updated and tweaked. It's just too fragile. Which brings us to our hero, relative XPath. This is the industry standard for a reason. It's flexible, it's resilient, and it gives us this amazing toolkit for writing locators that can actually withstand change.
And building a basic one is beautifully simple. First, you start with those double slashes to search the whole page. Then, you just name the tag you're looking for, like an input or a button. And finally, in square brackets, you give it a unique clue, like an ID or a name, to pinpoint the exact element you want.
But this is where relative XPath really becomes a superpower. It has these awesome built-in functions for when things get messy. What if the only unique thing about an element is the visible text on it? Easy. Use the text function. What if the ID changes every time the page loads, like user123, then user456? No problem. You can use contains or starts with to match the part that always stays the same. This is how you handle modern, dynamic websites. It's a total game changer.
And you can level up even more. Let's say a link has no unique attributes, but it's inside a user profile box that does have a stable ID. Well, you can just chain the XPath. Find the stable parent first, then navigate down to the child inside it. You can even use AND or logic to say, I need an input that is both a submit button and has this specific class name. It makes your locator ultra-specific and rock solid.
So when you put all of this together, this flexibility, this power, it's really no surprise that something like 90% of real-world automation projects rely on relative XPath. It's the professional standard because it's built for a web that is always changing, ensuring you can find your element not just today, but tomorrow and next month too.
So there you have it. We've gone from that soul-crushing, element not found error to having a robust, flexible GPS for pretty much any element on any page. The only question left is, now that you have the power to find anything, what are you going to automate?